want you to think about the last time you had a candlelight dinner. Did you think you were putting your health at risk? Well, did you know that paraffin wax candles emit toxic chemicals? And the soot from candles is the same type of soot that comes out of diesel engines? And the paraffin fumes have been found to cause cancer in lab animals? Well, thankfully, we no longer have to breathe all that toxic crap just to make light. And as our Schoolhouse Rock intro song taught us, Thomas Edison, with his little help from electricity, solved this problem for us many years ago. And this is a great example of how switching from a chemical technology, fire, to an electronic one can make things better, including cannabis. So I want to be your guide tonight and set the stage and really unpack all this complex machinery around vaporization technology. And Revel has brought on a number of amazing speakers, and they'll each take deep dives into their respective areas of expertise. But I want to start by just saying now is not the time to pause or rewind. Vaporization is an amazing technology that actually has some advantages over ingestion, and it's really important that this not stop, that this keeps playing forward. So with that, let's talk a little bit about what vaporization is. Well, here's an example system. It's simple building blocks. There's a battery, an electronic circuit to control the flow of electricity. There's a heating element that vaporizes a liquid. There's typically a wicking component that transports the liquid to the heating element, and an airflow path that brings in fresh air to mix with the vapor. Now let's take a little closer look. Here you see a video of a typical heating element, and it's made of a wire of a particular metal alloy that, unlike the wires in your home, gets really hot when you put electricity through it. And here it's actually wound around a wick that's been saturated with liquid. And what you just saw is that when you apply electricity, the liquid boils off and creates a vapor, kind of like boiling a pot of water. Now let's look at a cigarette. I don't even need a video to show you what's going on. You already know. This is unlike vaporization. This is literally a chemical flab on the end of a stick in real time, creating chemical components that were not there before it was lit on fire. And I think you know that if something as bad as a cigarette isn't causing people to rush to the hospital, that cannabis vapor should absolutely be safe. So let's talk about why vaporization is better. And let's use a lesson from my history where we compare the e-cigs we developed versus combustible cigarettes. Now, don't worry if you can't make out all this data. In short, it compares a number of different toxins that the government makes you look for. And importantly, what you need to know here is that nothing in here is particularly related to the burning of tobacco. It's the burning of plant cellulose. And guess what else has plant cellulose? Every single plant, including cannabis. So let's look at three metrics. Here, let's just look at carbon monoxide, formaldehyde, and heavy metals. And you can see just how much comes off of a cigarette, no surprise. Now look at the e-cig vapor shown in green. And interestingly, also look at an air sample taken from outside of the lab. Now, the e-cig vapor, yes, it had nicotine, but when you look at all the other toxins, it's indistinguishable from the air we breathe. But to get those results, you have to do it right. And how do you do that? Well, step one, you've got to have a good formulation. And as Tamara will tell you later, I'm sure, that it has to be free of contaminants. And ingredients are important too. What goes in, what shouldn't go in. But yes, ingredients are important, but so are amounts. I mean, something that may be completely harmless in small amounts, if concentrated up, can be toxic, even if it comes from cannabis. And unfortunately, we just don't have a lot of inhalation toxicity data to work with. So what do manufacturers, what should they do? Well, a good guide is stick close to what nature provides. So look, people have been smoking cannabis for centuries without having to be rushed to the hospital, right? Well, that tells us that in the amounts present in cannabis smoke, these compounds are relatively well tolerated. So again, stick close to what nature provides. Or use other things that have a significant vaporization history, like VG, not vitamin E acetate. Part 2, the hardware. Basically, the hardware can't take a good formulation and turn it bad. So here I want you to know that the formulation's applied at the end of the wick, and notice how long it takes to travel from the outer edge of the wick to the inner. And also notice how one of the part of the coil isn't even in contact with the wick. And what that tells me is that no matter how good my temperature control circuitry is, I'm still going to have local dry and hot spots that can lead to the creation of some of those toxins I talked about. And the same is true for ceramic-based systems as well. So what this really shows is that the performance is based on a combination of hardware and formulation. So we really need to test the system as a whole. Which brings me to my third point, which I think, testing, and Aaron will dive a little deeper into that later, but we really do need to test what goes into our body. And in this case, that's the vapor, right? Look, we don't drink the formulation, we inhale it. So of course we should test the vapor. Now, the good news is the methods for testing this they're currently used in the e-cig space, and they're easily adapted to cannabis vapor. But again, let me be clear. Currently, no one is required to test vapor in cannabis. And again, good vapor is not just a function of formulation. It's the whole enchilada. It's the hardware. It's the formulation. It's the testing all together. Now, let me rewind the clock to August of 2016, when FDA deeming regs came out and the wheels of innovation stopped, not just at Blue, but the entire US e-cig industry. First, there are no new legal US e-cig products. And what we're using today in the cannabis industry is largely based on a lot of those legacy technology and designs, which is why I left Blue, and brings me to my last point, data. Those legacy systems don't provide the data needed to grow and innovate. And as a matter of fact, we still don't have good usage and effect data for something as simple as a nicotine e-cig. And we all know cannabis is much more complex. And we need that data, not just for toxicity and thermal degradation, but data about users. Look, we all know with a plant with so many uses and such highly individualized effects, data is is absolutely critical. So look, we can no longer accept the status quo. Number one, we need to get a lot more sophisticated about formulation development. 2, we need to evolve legacy hardware systems. And 3, we really need to re-examine the way we test, including testing the vapor. And if we do all of this, we can put combustion behind us and realize the promise of vaporization, which leads me to the need to innovate, which is why I'm here. Here to do things that I couldn't get done in the past, and here as part of WITI to bring the connected health revolution to cannabis, starting with the launch of our 2.0 device in 2020. So I want to thank you for inviting me here. Thank you to Revel. I'm looking forward to joining the rest of the speakers in a panel discussion later, and hopefully that panel discussion will have a little electricity. Thank you.